Hey, this is an Arduino Uno with a USB host shield that's mounted onto it. There is a Bluetooth dongle which is connected onto the USB host shield, and the Bluetooth dongle pairs to our good old friend right here. Right. And what I do have here is a STM32F407 dev board, and I have a I squared C bus set up between these two. The STM is the main node, the Arduino being a sub node, and the reason for that is because STM works on 3.5 volt logic, while Arduino is inherently 5 volt logic. However, in an I squared C bus, the master or the main node is responsible for setting the reference voltage of the entire bus, depending on the serial clock. So what I'm trying to say is, if the serial clock is at 3.5 volts for logic high, that's what the entire bus's signal turns out to be. Cool. What I'm essentially doing here is I'm taking inputs from this joystick and doing something with those inputs on the STM32. I'll show you guys what's going on. So I have a feeder program on the Arduino side. The PS4's remote connects with the Arduino via the Bluetooth dongle. So this is entirely wireless communication. I can take the joystick's X, Y, and Z coordinates, and the omega is nothing but the trigger coordinate. So when none of the triggers are pressed, the omega is at 127. If one of the triggers is pressed, the omega is at 255, and if wait, hold on. If the other trigger is pressed, the omega is at 0. Cool. I am also taking 16 button inputs. So the two triggers right here, the two triggers right here, the share, the option, the PS button, the joystick click, the other joystick click, these four and these four. So every single input that I can take from the PS4 controller is being taken onto the STM32. And I'll show you guys how am I doing it, or what's exactly going on over here. Cool. So you do see a stream of values here. The x, the y, the omega. These are the same as the one we saw on the Arduino interface. The x and y are coordinates of the left joystick, right? And the omega is the coordinate for the triggers. Cool. I'll switch over back to the STM's debug console where I'm printing the values that I receive, right? And I'll just make it a bit big for you guys because size indeed matters, right? And as you can quite clearly see, if I take the joystick down to the leftmost extreme, the x coordinate goes to 0. If the joystick goes to the rightmost extreme, the x coordinate goes to its max. For the y, if the joystick goes up to the most extreme that it can go, the y coordinate will be 0. If it goes down, the y coordinate will be the max. Cool. As for the omega, if I trigger the left trigger, it goes on to 255. And if I trigger the right trigger, hold on, let me trigger the right trigger. If I trigger the right one, the omega goes to 0. Now, you might see B1 and B0. These are button group inputs. So what I've done is I have assigned so B1 and B2 are uint8 values. They are 8-bit unsigned integer values. And if I press a button, right, I've basically assigned individual bits of the uint8 onto these buttons. So the B1 group is for the X, the triangle, the square, and the circle, and the up, down, left, right buttons. The rest, are for the joystick click. So if I click the joystick, the B4 will toggle its value. If I click this, the B2 will toggle its value, and so on and so forth. I have a bunch of other options. The cool thing about this is I can detect multiple button presses at the same time. So for example, if I press the X button, B1 goes to 1. If I press the square button, B1 goes to 4. Watch what happens if I press both of these at the same time. Right? If I press both of these at the same time, so one of them is corresponding to 1, other is corresponding to 4, both of them at the same time correspond to 5. Same for these two buttons, correspond to 10. Individually, they are 8 and 2, right? Goes for these two buttons as well. So you get what I'm trying to get at, right? Now, one of the more common applications of doing shenanigans like this is that that you can essentially hook up an entire robot's control system onto your STM32. And you can control it via your joystick. And I have a small visual representation for this as well. So what I have done is I have a timer onto the STM32's dev board, where all the four channels of the timer are mapped to four individual LEDs. So what I've done is I have mapped the X and the Y onto these four LEDs so that I can represent a coordinate system, and I'll get to it how in just a minute, right? So let me set it up. So what essentially happens is, if I go over here, the rightmost LED starts blinking. If I go down here, the bottom LED starts blinking. If I go to the leftmost screen, the left LED starts blinking. If I go right up there, the top one starts blinking, right? And if I go anywhere in between, the corresponding pair is supposed to light up, and this is how the whole operation is supposed to go. Now, the cool part about this is, imagine that these four, LEDs are not LEDs, but they are the wheels of a four-wheel chassis. What you can essentially do is you are mapping a two-directional input, the two directions being the X and the Y, onto a 2D coordinate system, and you can control physical systems with all of it, right? And if you have a bunch of mechanisms on your robot, the button inputs can essentially act as triggers for mechanisms. So that's how robot controllers are made. A very rudimentary form, a very college robotics form of robot controls are being made that way, right? And this indeed was what I used to do in my college when I was with my college's robotics team Automatons. And yeah, it's just a cool project that I have that helps me explore a whole lot more. Now, I do plan on getting some sensors in the future. If anyone is willing to sponsor sensors for me, please do. Get in touch with me. We can talk, right? But yeah, this is what I wanted to show. It's kind of cool, right? Don't you agree?